Hello, good evening. Welcome to the Railway Civil Engineers Association. I'm Jonathan Butchery, Chair of the Railway Civil Engineers Association. And this evening we've got a fascinating talk on Werrington Grade Separation project. Brian Ingram and Anshal Chaturvedi are going to be talking to us about this fantastic project to build a dive under below the East Coast Mainline that's been recently completed. A curved double track dive under has been slid into position below this vital railway route in the UK. So we're very much looking forward to that talk. Firstly, apologies for a few minutes delay this evening, just whilst we got our IT set up. As often the case, there are sometimes last minute glitches with the technology, so apologies for that, but hopefully we're going to have a really good talk for you. This is our last talk before the summer break. We just take a little bit of a break and we'll be coming back in September. So we have a talk lined up in September on the case for rail infrastructure investment, particularly post-COVID. We've got a number of speakers lined up for this, including we hope to have the DFT for their view on this, but obviously we're all very interested as people working in the rail industry on what the business case for these projects and works is after COVID and with possible reduced transport demand. So we're going to have business case analysts, experts, people, experts in future passenger demand modelling and the DFT there to be able to talk about those three aspects really of what we think travel patterns might look like after COVID, and obviously a lot of people don't know about that, how it might affect business case investment and how you actually do that business case analysis. So that's on the 23rd of September at 5:30. You can book all our events at the ICE website /events and just search for rail events. However, if you want to get the lowdown on these, and if you're interested in railway civil engineering, join us. It's just £18.50 for a year for a full member, reduced rates for graduates and retired members, and free for students. And if you do that, you get free mailings on our events, and also as and when we are able to arrange special events, including site visits in the future, you'll also get the opportunity to come to those. So do join us if you're interested in that. And we're open to civil engineers in the industry, in the rail industry, but we're also open to other professionals working in the industry. So we welcome members. Okay, well, I think without further ado, I'm going to hand over to Anshal, who's going to start our presentation. So Anshal, if you'd like to start sharing screen, and I'll switch off my camera as well.
No worries, Jonathan. Thank you. I'll just bear with me a second whilst I... Right, can you see that?
Yes, we can at the moment. I think my camera's still switched on, so I'm just going to switch that off, but yes, that's great, and we can see you as well. Thank you, Anshal.
Okay, excellent. Well, firstly, hello everyone. Thank you for joining us today, and thank you to the Railway Civil Engineers Association for giving us the opportunity to talk about Werington. It's been an excellent project to work on, so we're very happy that we're able to share this with you. As Jonathan mentioned, we've got Brian Ingram, who is the contractor's responsible engineer for the portal push, which you will hear from him in a second about what that means, and myself, Anshal Chaturvedi, I'm the scheme project manager for Network Rail. So in terms of Werrington then, Werrington Grade Separation as a project introduces a new dive under that provides an alternative route to an existing flat crossing at Werington. This flat crossing was causing a major bottleneck between the slower freight trains on the Great Northern, Great Eastern, or the GNGE lines, as you'll hear us say, and the high-speed East Coast main lines, or the ECML lines. So the dive under provides an alternative route by enabling a two-track railway underneath the East Coast main lines, and it separates the freight from the high-speed passenger traffic. Those were the two briefs that we had from the client. However, as a part of improving outcomes and following on from Network Rail's value of putting passengers first. An additional scope was added onto the project, which was to increase the passenger capacity during the 9-day closure of the railway, during which we would push the portal underneath the East Coast Mainline. So this came about in the form of a bespoke bidirectional signalling solution, which was delivered from inception to operation in just over a year. And what that did was it more than doubled the number of available seats during the partial closure for passengers. If I speak quite briefly about just some of the benefits that the users will get directly from Werrington as a project, would be an additional 2 long-distance high-speed trains per hour and enhanced freight carrying capacity underneath the East Coast Mainline. But just speaking about then where Werrington sits within the industry, Werrington is one of the crucial schemes within the £1.2 billion East Coast Upgrade Programme. This programme also includes the likes of major schemes like King's Cross remodelling, Stevenage Turnback, and power supply upgrades on the East Coast. So as you can see there, the East Coast Upgrade is a major programme, and Werrington forms a crucial part of this programme. And just quickly touching on what the East Coast Upgrade means in terms of outputs and outcomes for the stakeholders. So Werington, the 9-day partial closure sat in January. We had a King's Cross partial closure until earlier this week and then on Monday successfully King's Cross remodelling was completed, with Werington scheduled to complete in November 2021. What that would mean as a service change for the next timetable change would be, as a benefit, would be 8 long-distance high-speed trains between King's Cross and Doncaster, 6 long-distance high-speed services between Doncaster and Newcastle, and the travel time between King's Cross and Edinburgh for the fastest service would be 4 hours, and between King's Cross and Leeds would be 2 hours. So lots of benefits within the East Coast Upgrade Programme in itself. So if we go back to the delivery model of Werrington, so the delivery model was a hub and spoke model, and what that did was it drove early contractor engagement into the early design stages of the project. This was quite fundamental for us in terms of delivering the program to budget and to schedule, but also in delivering a solution which was crucial to minimise disruption to operational railway. We also engaged with multiple stakeholders, as you can see on the right-hand side of this slide. So and loads of delivery partners. So that included utility companies, included the environmental agency, and throughout the project we ensured that we had consistent communication and buy-in from these external stakeholders, such that utilities and protected species could be diverted or relocated as a result of the project. What that did was, again, it supported us in timely delivery and cost savings. We also pride ourselves on the excellent communication that we've had with the community around the project. So we had monthly drop-ins, newsletters, all of this obviously pre-COVID, and then even throughout COVID, we've maintained our communication, and Morgan Sindall have held numerous talks for school careers fairs and local interest groups. One of the most important things to mention here would be that the scheme was designed and staged with the passenger in mind. So some of the things that we did to ensure that we put passengers first was stage 1 of the project was slewing some of the lines to create a wide way, which you'll see what I mean in a second, and that included a lot of utility diversions, and all of that work was done in order to ensure that the project could be built whilst allowing full train services to run within the area. We also had state-of-the-art monitoring, which allowed quite critical activities to go ahead, such as tunnelling and piling, and all of this whilst the railway was still open. And lastly, we planned and planned. So multiple peer reviews, internal and external industry stakeholders. We had quite an onerous process to ensure that detailed and contingency planning was undertaken to make sure that we would deliver the scope within the 9 days. So in advance of the 9 days, there were some enabling stages that I'd like to quickly mention before we get to the actual push in itself. The first one being quite a major milestone for us, and that was slewing of the Stamford lines. So I'm not sure if you'll be able to see my cursor, but just on this screen here, the tracks in the lines in green were where the old Stamford lines were. And for the first stage, first milestone of the project, we slewed them over to create a space which we referred to as a wideway. What this wideway would do would be to make room for the ramp leading into the new dive under lines. In order to undertake this phase, we had to do a lot of enabling work. So this bridge that you see up the top here, that's called Cochlear Footbridge. So we needed to replace an existing pedestrian footbridge with this to ensure that the span was widened to allow for the new lines. We diverted this river here, which created a biodiversity gain. It created room for the wildlife to settle during storm surges, and we worked quite closely with the environmental agency to ensure that this sat with their current plan. There was also 500 meters of river that needed to be diverted south of this bridge, and that what we did for that was to create a box culvert in situ, and we had the new Stamford lines, or the diverted Stamford lines, sit on top of this box culvert. A lot of this work was undertaken during disruptive Christmas possessions, so it was quite important for us to deliver those on time. The things that I haven't mentioned here are overhead line works that needed to be done in order to slew those lines, and all of this to create that wide way to make sure that the passengers were put first, and we would be able to construct this project with minimal disruption. Moving on then to a few of the other enabling works. So the north ramp was constructed by installing 183 board piles and over 900 soil nails, and it was finished by a sprayed concrete finish, as you can see in that image there. In total, 120,000 cubic meters of soil and clay was excavated to create this nearly a kilometre long ramp. And the final fit out of this ramp is well underway and will soon be ready for track installation. If in the aerial photos, you can see a couple of bridges, so some utilities needed to be diverted. We installed a temporary footbridge, if you're able to see here, to divert these utilities temporarily whilst we added a new span to the permanent footbridge, and then diverted all the utilities onto the permanent footbridge. And as of the weekend just gone, we've dismantled the temporary bridge, and the permanent Lincoln Road Bridge is up and running. Similar to the north ramp, then over onto the south ramp, we created this wide way. As you can see, these lines are now slewed. We created this wide way to create this ramp. This is the bridge that I referred to earlier, and this ramp in itself is also about 1 kilometre long, and had 66 board piles just for the reception pit in itself, where the tunnels went, and 693 board piles all the way through to the ramp, with some sheet piling here as well. So major works, major enabling works undertaken to ensure that the portal push would occur. As you can see in this image, this is what the south ramp looks like. So fresh bottom ballast, ready for track install. And then we get to the 9-day partial closure. So before I pass it on to Brian, the thing that I'd like to just quickly touch on is that bi-directional signalling system that I mentioned earlier. This photo does quite a lot of justice to what that meant, because as you can see, this is where the portal is nearly in its final position. You've still got a long reach excavator undertaking those excavations, but then actually you see an East Coast mainline train running, and all of that was due to the bi-directional signalling system that we installed. So that was quite a success for the project. I'll hand over to you, Brian, now to go through what the 9-day partial closure was all about.
Thank you very much, Angel. And just to explain, unfortunately, we're not able to do video link with Brian, so apologies for that. So we've switched your camera off. But Brian, thank you very much for joining us. Over to you.
That's all right. I hope you can hear me. So the 9-day blockade, January. The tunnel construction, or the portal construction, involved driving 2 tunnels underneath the East Coast Main Line to install pre-install a slide track, and then the portal structure itself was built offline, ready to be pushed into place. The concept is a curved portal. Sorry, Angel, I think that's next slide. Is a curved portal. It's the first time a curved portal was used in the UK. So it's certainly the first curved structure we're aware of that's been installed in this specific method, and is unique as an innovation. It involved sort of 2 guide tunnels. The guide tunnels were put in ahead of while the East Coast Main Line was running, and a jacking slab was constructed on the launch side. A cutting head was put on the front of the portal, and we set up at the back with some jacking operations to push the portal through. Next slide. So the tunnelling itself was undertaken with a Lovett 132 TBM. So drilling a 3.35 metre diameter hole. The structure itself was on a constant approximate 750 metre radius. It was 165 metres long, an internal diameter of 2.85, and it was drilled through Oxford clays, through a T3 head wall that was contiguous board piles with GRP reinforcement in them. The next slide, you can see a picture of the inside of the tunnel, ready for the slide track to be fitted, and that is a bit tight for space, but you can see the curvature of the tunnel ahead. Going down to the next one, the portal construction was built offline. It was built on a jacking slab that was both foundation for the structure in its temporary state, but also it acted as the reaction slab for the jacking operations themselves. and took all the thrust loads. It was actually, there's piles underneath it as well to help transfer the thrust loads to the ground. And then the tunnelling itself was fitted out with a reinforcement cage, both a base and a guide wall. This was prefabricated on site, but away from the tunnel and lowered down into the tunnel, and then pushed into place through the tunnel and concreted in place. On top of that, there was fixed a steel plate for the to take the PTFE pads, which were the slide medium, and also a guide plate on the wall, which acted as the steering plate for the pushing and guidance system, and to help the box go around the curve, or portal go around the curve. Once that was fitted, the portal itself was fitted with a series of jacking bits of equipment. So that was really in three parts. There was a lift system and a skid shoe system that is, you can see like a red beam that's underneath the portal, and that's got lift jacks on it to allow the load of the portal to be transferred onto the skid system. PTFE pads underneath that, and it's a stainless steel underside to the skid beam. There was also a guidance system that steered kept the structure sort of central within the guide walls. And then lastly, there was 4 propulsion jacks at the rear of the structure, which were 1,250 tons each, 3-meter stroke jacks that pushed the whole system along sequentially. In the partial closure, it relied on us digging ahead and staying ahead of the jacking system. So we had to shift 11,000 tons worth of earth out in front of the portal. The OLE was raised to give the excavators space to work, and the new OLE equipment was designed with a 5-meter non-effective depth of OLE, so to allow loss of material, passive resistance around the piles themselves. So it's a fully integrated design solution. So in the portal, partial closure, had a crane at the back handling the jacking frames. We had the propulsion jacks at the back. All of that hung off the back of the portal. We had some framing just at the front as the excavation got deeper, which we had to get ourselves in a position where we could work under that sort of fairly rehearsed sort of construction method. At the front of the portal, the box was fitted with a cutting head, and that sort of cut the soil at the side. 50-ton excavator at the front kept the earthworks ahead, and we had a smaller excavator at the front just handling the segments of the tunnel. The tunnel itself was pre-cut prior to the possession to allow us to lift out the segments as we went. In terms of the closure itself, took possession on the Friday, late PM, and the track and OLE were out by Saturday, and the jacking operation and structure was pushed into place by the Thursday, with a handover to track late sort of Friday, and then track handed back with everything in trains running Monday morning as planned. So very smooth delivery. And we have a video next, so I'm hoping that will play. That's playing. I can't see it on my screen.
It's playing, yes. I don't know if there's
Yeah.
music, but I'm sure we can live without the Network Rail official music.
Yeah, that's so that was it in action for that. And in terms of lessons learned, what went well, the planning and pre-planning methodology, peer reviewing, having people who are experienced. Oh, we've got more video by the looks of it. That went really well. We trial pushed the portal 21 meters, and we excavated out ahead of the portal pre-possession, just to get as close to the railway as we could. Communication reporting in the blockade, it was very good. We had the program broken down to individual elements of that fitted into the reporting cycles, and we also live revised the program during the blockade. And the installation of the bi-die working really kind of kept the lines open and allowed Network Rail to run services during the portal push as well. In terms of challenges that we had on the day of the race, as it were, weather conditions were appalling. It snowed. It was very wet. Pre-blockade, we had to deal with COVID-19 restrictions that placed caused a bit of a delay to the tunnelling, but we got to the January possession on time. And we also had a challenge with the PTFE pads, where we had a bit of a supply issue there, so we were able to swap the PTFE pad system for Mammoet's standard PTFE pads, and they were able to. We dragged those in from all over the world, and were able to use them in the blockade to sort of keep things on track. So that's kind of my bit of the presentation. So I'll hand back to Anshel. That's okay.
Thank you very much.
You happy for me to go ahead, Jonathan?
I certainly am, and yes, we'll feed any questions and answers at the end of the meeting. Not had many questions yet in the chat pane, so any people in the audience, please, if you'd like to raise any questions, please do. If you click on the little Q&A panel, there's a little question mark with a bubble, and type your question in there. We'll go through them all and publish them, and we can have a bit of a Q&A session at the end of the meeting. Okay, over back to yourself then, Anshel. Thank you.
Thanks, Jonathan. So as Brian mentioned, the 9-day partial closure in itself had a lot of moving parts and elements, but a lot of planning went into place for us to ensure that we were able to deliver the entire stage within the planned 9 days and be able to hand back on time. But that wasn't the end of it. There is still a bit of work to do to ensure that the new lines can be put into operation and entered into service. So if you can see on this diagram here, and actually find it quite useful, which is why I continue to refer to it, but essentially lines 2 and 3 are the new dive under lines. So what we've completed so far is we did a slew of the Stamford lines here, and then as of the weekend just gone, we have slewed this green line back into what is going to be its permanent position, which is number 4. The dive under lines will now be, as the ramps are nearly ready, and so is the box for us to install track, which will be done in the next 5 weeks within the dive under lines. We've also completed the tie-ins for the permanent Stamford lines here, and we just need to finish the tie-ins for the dive under lines. Post this, we'll also have final signalling install and power works to ensure that we're able to commission the signalling system in its entirety by September 2021. If I move on to the next slide then, apart from the actual dive under lines in itself, we're also undertaking quite a major civil operation in constructing a siphon structure. So the problem statement here was that we had a utility that was right in the way of the north ramp, or where the portal was supposed to be constructed, and in the way of the dive under lines, which was a water pipe, a surface water pipe. So in order to divert that, what we've had to do is to construct a siphon structure. So the pipe comes in here, it will be intercepted through some drainage here, and then within these shafts, which are 14 meters in depth and 9 meters in diameter. So that kind of gives you a scale of how large the structure is in itself. And it will go underneath the new dive under lines and come up through the shaft, and then be diverted into an environmental agency brook just south of this photo. So that's quite a large operation. We've managed to deconflict it from entering the lines into service by constructing this overpumping system. And so currently, as we sit, the water asset is being overpumped over the dive under, and then once the siphon is complete, it will be going underneath. And apart from all of those other things, there's just a few other stats that we thought would be useful to mention to give you an idea of how big the project basically is. So we've installed 8 kilometers of new track. As we've said before, the structure in itself was 11,000 tons and heavier than the Eiffel Tower. What was unique about it was that it was curved and it was jacked at a curve, which in itself was quite a challenge. We've installed over 8 kilometers of overhead line equipment, 2,000 piles and soil nails. As Brian mentioned, we had 2 guide tunnels installed underneath operational East Coast, and that was due to the fact of innovative surveying equipment. We have had a lot of spoil excavated, 250,000 cubic meters to be exact. 4 new sets of S&C, nearly 2 million hours of hours worked to date, and that doesn't include the initial optioneering of the project. If that were to be included, I believe it's close to 6 million. 2 protected species were translocated, and we've actually managed to get a 16% gain on biodiversity. We've diverted 20 utilities, and I see there's a question about utilities, so we can get to that in a second. We've renewed an existing signalling area, and we've modified 5 bridge structures. So apart from just creating a new dive under, we've also done a lot of work to ensure that that is enabled. And to conclude, this was what the site looked like on the morning when we opened up. This, as Brian mentioned, it was snowing and it was very difficult. However, it made for a really great picturesque finish. And as you can see, the portal is in place now. We've reinstated the East Coast Mainline, and there's a train going over what is now the newly installed portal. So that's the end of the presentation. I'm happy to answer any questions.
That's fantastic. Anshel and Brian, thank you very much for giving up your time to come and speak to us about this. This is really interesting for us. This is classic railway civil engineering. As a graduate 21 years ago, I worked up in York on a scheme called Peterborough Area Remodelling Scheme. And the plan in those days was to actually drop the fast lines of the East Coast Main Line down into a dive under slightly south of where you are, and have the slow lines and the freight routes cross over the top. Sadly, I think Railtrack going into administration put a kibosh on that, and so 21 years later, it's good to see the scheme that actually happened.
Your loss is our gain, Jonathan. So
thank you very much. Yes, yeah, no, that's true. That's true. I didn't get the experience of that, but at least I get to hear about it now, and I get to see the end result. So that's fantastic. So we've got some excellent questions on the right. If you like, I'm happy to feed these to you. I'll try and run through them and cover them as best I can in order. Please, members of the audience, feel free to raise anything. We'll publish them as soon as we've reviewed them, and we'll discuss them. So if I go down from the sort of top downwards, question from David Coles. David, thanks also for helping arrange this meeting. Anshel, HS2 and Highways England have suffered some significant delays with utility diversions. Any tips?
It's always quite a tricky one, isn't it? And I think because utilities have a lot of statutory powers on their own, I think there is a lot of protective provisions put into place to ensure that they are protected, and that could be to the detriment of the project program. I would say early engagement is quite an important one to ensure that we know where we are. I understand that and appreciate that that's not always possible, considering funding constraints and surveying of the area may not be possible when you're putting together a business case for a project and that funding's not released. So it is quite a tricky one, and I think it continues to be a tricky one. However, I would say what worked quite well for us was early and constant engagement of the utilities to come up with the best solution.
That's great. Thanks very much, Anshel. And Brian, feel free to chip in if there's anything you want to add, or interrupt me if there's anything I'm saying that isn't quite right. Next question is actually from myself, which was, what was the reason for a dive under rather than a flyover? Apologies if you've covered that in the talk, but and were there any issues with groundwater because we went for a dive under?
I'm going to let Brian take that one.
I think both were put out for consultation at the planning stage. Certainly when I was involved in it. When it came out for tender, it was definitely a dive under structure, but the land take for the flyover structure, because you've not only got sort of deck thickness, a deeper deck thickness, but the land take for the flyover structure was much larger, as well as being much more visible.
So was that to minimise the impact effectively on the environment and the neighbourhood?
I think so, yeah, and just physically fitting it within the site. The dive under structure works quite well in terms of dropping off and dropping onto the lines. You can imagine the sort of deck thickness that you'd have with a very heavily skewed structure spanning over the East Coast Mainline. It was quite a structure. So I think it was discounted both for visual reasons and for land take reasons.
Do you think that costs the railway more to do that, to kind of improve the environmental impact? If I'm not paraphrasing there. Box jacking isn't a cheap solution, but once it's set up and ready to jack, it's relatively straightforward. It's just the temporary works that sort of gets in the way. It's quite expensive, but I don't know how they compared cost-wise, the schemes. But I suppose it's academic if it's needed for environmental reasons. You're putting a new railway in there, and the impact is much lower. And as you say, it would have been a pretty big structure if it been going across the main line.
And in real terms, groundwater does appear high on the structure on it, but it's actually the ground is not that porous, so it doesn't kind of flow into the project. You're not. And
does the drainage, presumably it requires pumping, does it, to get the water out the dive under?
It requires pumping out the dive under, yeah. It drains into the siphons, which Anshel showed, and then from there it gets sort of picked up and pumped into the watercourse at high level.
Fantastic. So I'll move on. Next question is from David Coles. Roughly how much did the temporary bi-die signalling cost, and Just out of interest, which line was that? Was that the down Stamford that was made reversible, or I've probably got that wrong? Which track was it that was made bidirectional?
Yeah, if you bear with me a second, I'll go back to where we had the bidirectional photo.
That's great.
So apologies, I've had to.
Yeah, we can see it scrolling through the pages.
Right.
And that's just me asking to orientate myself, but
No, and that's fine. So there we go. So it was the bidyne itself was over where the temporary up Stamford was, which is now removed, and it is now in its permanent location, which is number 4. Sorry, there's this line here which doesn't exist on this page anymore. So that's the temporary bar die was on this line.
It's one of the Stamford lines.
Yeah, correct. So it was the one that was slewed but doesn't exist anymore. The panels are being recovered as we speak. So
just was that the non-electrified line? Because I know the down Stamford is also the down slow, isn't it? And that's electrified.
Yeah.
So was it the non-electrified line that you used bidirectionally, or?
So I believe it was electrified, but but I am perhaps not the best person to answer that question, Jonathan. But I do believe both the Stamford lines were electrified in order for us to slew them in the first place.
So you could use electric trains. You didn't have to use the hybrid, the diesel engines of the hybrid trains to get
Correct.
through there. Then.
Yeah.
So I've deviated from David's question, which was roughly how much does it cost, the bi-die signalling?
And that is another good question, David, that I may have to come back to. I have consulted some experts, but since this was delivered within the scope of the project in itself, but sort of outside the remit of the main works, it's not something that I'd be able to comment on yet. But
Okay.
however, I'm hoping that by the end of the questions, I have an answer for you.
Thank you very much. That's much appreciated. Okay, I've got another question. Why couldn't all 4 lines be slewed temporarily, negating the need for the slide manoeuvre? So I'm sure there's a reason for that. Maybe that's one for Brian, but
I don't really know the sort of history sort of too much behind what was developed. But when the project was originally tendered, it was sort of like a half and half type construction, building one half and building the other half, which was the original concept, sort of slewing the lines as you go. 3 contractors tendered for the project, and two of which came up with a box jacking in a short blockade. So financially it makes sense from a program point of view. It makes sense to build it in one hit and push it into place, just because you've got.
Just out of interest, what grip stage was that, Brian, when it was tendered? Was it design and build?
It was grip 3, design and build, I think it was. So I worked on the Carillion tender, but sort of Barron and Morgan Sindel were both came up with box push offline.
I see. So you took that through grip 4 and grip 5, and obviously through to construction.
This one came through. Morgan Sindel took it through grip 5, I think, but it was before I kind of joined the project.
Okay. The next question I've got, project question really, but what was the cost to benefit ratio for the project? I assume overall. So the cost benefits to the railway, I suppose, from having this dive under at Werington on the East Coast Mainline. Any comments on that?
I think, as previously mentioned, Jonathan, in terms of the benefits of the Werrington project and the East Coast Upgrade Programme as a whole, in the extended or exceeded capacity and decreased travel times, but also increased capacity for freight, is the cost to the benefit to cost ratio is quite high, because it's essentially ensuring that there is more capacity on the East Coast, and that's all aligned with what the client required and what Network Rail's putting passengers first value is all about. So delivering benefits in terms of the entire scheme or entire program, they're quite high when it comes to comparison with cost.
Okay, no, thank you for that. And yes, I guess if you want to run more trains on East Coast Main Line, which we probably do, you've got to tackle problems like this. So yeah, thank you for that. So we've got another question here. Whilst I'm all for minimising disruption to the railway, it seems like this meant a much more complicated solution was required. How do you assess the inconvenience versus the assumed additional cost of a complicated solution? So I presume they mean, could you not
Traditional methods?
I guess so, yes.
Yeah.
I don't know what you, yes.
So in terms of traditional methods of constructing a structure like this, and apologies, Brian, feel free to jump in at any point, but a traditional sort of method of constructing a dive under would take about a month's long disruption, and that is just in construction of the structure in itself, if it were to be constructed in situ. Additionally, in terms of the spatial constraints on either side, which, as you can see in this photo, we've got a business park on one side and utilities and farmers' fields and stakeholders, and a data center not too far away from there. That would be quite a constraint as well. So the inconvenience would be quite a lot more than what we perhaps can envisage. And I think a complicated solution was the best way to go to ensure that we minimize that disruption.
Yeah, I think you know, it's not uncommon for building structures line of the railway and sort of moving them into place. And this is just kind of one variant of that. You know, you see many structures going into place with SPMTs or you know, being built offline and carried into place with various jacking methods. So this is kind of one just one system that kind of is similar to that. I think the thing that is unusual about it is just the geometry. You know, the squarer you go to the track, the more land take you would need to create the junction. And the curved structure is the simplest way of keeping that junction compact. So, you know, I think it's, you know, if you were to try to build that in situ with a heavily skewed structure, I don't think, you know, the structure would be enormous. You know, and the blockade would be enormous to try to do that.
I think that's very interesting for us, really, on the geometry and the track geometry, and the going for a curved structure and the amount of space it saves. There's definitely situations where that applies elsewhere on the railway. So I'm sure there's some learning there.
You could take this scheme and apply it to pretty much Wigston Junction, and it would be more or less there. You know, it's not dissimilar geometry.
Well, this is good, and I think that's the benefit of these kind of talks and events, is it's seeing somebody who's done it. So obviously, one thing designing things, but it's another thing to actually see a project that's built it, and that's where it's really excellent to see the learning, the experience that's been gained from that. Okay, a few more questions. I think we're open to a few more as well. Graham Bucknell's asked, how long was the programme from first taking possession of the dive under area to completion of the reinforced concrete structure? So from first taking possession of the dive under to completion of the structure, jacking rail tunnels and all the other works in readiness for the jacking weekend. So I suppose all the advanced works and everything building up to that.
Yeah. I'm not sure how long the overall project was, but I arrived in February 2020, and we were just starting tunnelling under the East Coast Main Line, and we'd finished the structure in its sort of pre-jacked position, you know, in readiness, or with probably by the end of July, and the tunnel fit out and the tunnels were completed, ready for the trial push in December 2020. So, you know, the best part of the year to get the structure ready in a pre-push position. Before I joined, there was obviously the brook drain diversion and substantial works on the other side of the railway as well, reception area. You know, I think that was probably another year, the year before that as well. So yeah, there's quite a lot of setup time for these types of structures.
Okay, fantastic. I think I've got about 5 more questions, so I'll just go through those. How did the timing of the other East Coast Mainline schemes impact on when Werington could be undertaken? That's Steve Lee.
So yeah, so I suppose from an access perspective, and that's a really good question, but the access and what we did quite well at Werrington, what worked quite well, was getting the industry bought into the project as opposed to having just a project approach. So having the Tox and Fox aware of what we were doing, and then ensuring that the industry was aligned with the program timescales. It actually did not cause much disruption to have other East Coast schemes impact on when Werington was able to be undertaken. I believe we planned it to make sure that the disruption was undertaken not during King's Cross's partial closure. However, from an industry perspective and from stakeholders such as train operating companies and freight operating companies, we had them on the journey with us to ensure that they knew what was happening on both of those major projects.
Fantastic, thank you. Another question, were there any specific measures taken to minimise the long-term track settlement risk from variations in support stiffness? So you've obviously got a new box. I'm sure you can see the...
Yeah. So the structure itself set a very high skew to the railway, but the measures that were taken was the method itself, the cutting method itself, because you're cutting the sides and bottom at the same time, minimises the amount of backfill that's needed adjacent to the top of the structure. So the technique itself minimises that kind of volume. Plus, the other measure that was taken was that within the fill profile at the top, that was placed square to the railway rather than square to or perpendicular to the railway. So effectively, the transition stiffness was managed by the sort of trains coming on to a sort of constant thickening and wedge of 6N material that was perpendicular to the track rather than parallel to the portal, which would have put it at a high skew to the track. So I hope that kind of is.
Yeah, thank you. I think it's an area of concern for a lot of projects, obviously, where you're putting any kind of solid structure like a bridge in, and what differential movement you might get, and do you get a hard spot? But it sounds like that's something that was well considered. Sorry, go ahead, Brian.
The twist was a big factor in the design, so sort of minimise, trying to get even stiffness across the individual tracks was sort of a real priority.
Presumably, yeah, exactly. With 125 miles an hour on the fast lines, yeah, tolerances for twist must be very low. So, although I guess they opened with a bit of a speed restriction for a while, not been through there for a while on the train, but yeah. Okay, next question, Bob Gardner. Very interesting presentation, thanks. Will all clearances and parapet details on the new GNGE route, that's the lines passing under the dive under, do they permit future 25 kV overhead line electrification?
I think so. Yeah, I think they do.
Yeah.
Question I'm not asked, but yeah.
I believe they are future-proofed for overhead line installation.
Just out of interest, I don't suppose either of you know what the rail to soffit height is then through the dive under, just out of curiosity.
I think it's about 5.2 metres offhand.
Okay, that would comply with the track design handbook for OLE. So that's a traditional starting point for OLE with a reasonable amount. Of course, the TSIs can sometimes make things a bit more difficult, but yeah, I suppose being next to an electrified line, albeit you could debate how soon they'll electrify the route through Lincoln. But if they ever do want to run electric float that way, then that's an obvious passive provision point. Okay, Ralph Bailey asked the question, which aspects of the project used patented techniques? That's not what I thought of.
Ooh. So I believe the curved portal structure is patented by Jack Structures. There's the other aspects that are patented within these types of structures are usually the anti-drag system, but we didn't use the anti-drag system here. But I think they have patent on the curved concept of this. So
which company is that, Brian? Is that
that's a company called Jack Structures, who are a sort of specialist in this type of structure. They've kind of grown out of the old cementation and John Hopkins sort of company that was around. And you know, when we used to do it with Trafalgar House and things like that. So
yes, yeah. And what aspect of sort of the curved structure is if you like, is patented, if it's possible to explain?
I think it's just the concept of it being, you know, offline and curved. You know, building structures offline and pushing them in is not particularly new or patentable. The anti-drag system itself, John Hopkins held patent on it for a long while. I'm not sure if that's lapsed or not, but still around. But the curved concept, I think, is held or built under license, or we've built it under license from there.
Okay, thank you. Just one more question I've got then, and then we'll I think we'll probably wrap up. But Bob Gardner also, forgive me if I missed it, but can you please confirm the drainage and pumping arrangements required to avoid the dive under flooding and the installed capacity? So I think you did mention that it pumps out to a sump.
The drainage itself. So the drainage itself falls to a low point in the portal, either side of the portal. And that drains to the siphon arrangement, which Michelle showed on plan, and then from the siphon it's pumped to into the local water course.
Okay.
With a discharge license.
Yeah. Okay, well, thank you. Just one last question from me. You probably said it in the presentation. What was the total cost of the scheme then of putting the dive under in? Sort of everything as a project cost.
So the total cost of this scheme, which was budgeted around Group 3, Jonathan, was circa between 230 million to 250 million pounds. We're not finished yet, but we're still at the lower end of that range. So.
That's great.
We've still got a sort of value engineering sort of project going on to ensure that we continue to stay there.
Okay, no, that's great. I appreciate you're not fully finished yet, and you've obviously got sort of final works and close out and everything to do as usual, but that gives us a flavour of what it costs to do a scheme like this on a very busy bit of railway, on one of the busiest routes in the country. So yeah, well, thank you very much for that, Anchel and Brian. A really interesting talk for us on a fascinating scheme. Thank you very much for giving up your time and coming and speaking to us. It's really been of interest. Thank you also to David Coles, who I think facilitated the talk through being the point of contact and asking you to come along and do this. David is a former chairman of the Railway Civil Engineers Association, and long-term railway civil engineer and professional, and has been shortlisted for the ICE Council elections this summer. So could I encourage members and attendees, if you're members of the ICE and if you have an interest in this, if you'd like to have a really good railway civil engineer on the council of the ICE, to probably not do what I do and normally ignore these things, but to dig out the emails from the ICE and respond to them, get your vote in. I think it closes at the end of July, but there's nothing to stop you just doing it now. So if you've got an idle minute or two after this meeting, perhaps dig out your email, and if you feel it's appropriate, consider casting your vote in favour of Mr. Coles. So I think without further ado then, our next talk is, as I say, on the 23rd of September, about the case for rail investment in more projects like this. Keep in touch via, if you're a member, you'll get the mailings from us on our talks, and we've got more talks and events lined up in the autumn, or indeed via the ICE website. So I'd like to thank everyone for your attendance and the questions that we've had. Really good to see you here. And we'll say goodbye. Anchal and Brian, you're welcome to stay on if you want to have a little word and a thank you after the talk. But otherwise, I'll say thank you to the audience and wish you all a good evening. Good night.
Cheers. Thank you.